Calculating absolute entropy using the Boltzmann hypothesis. Well, first of all, what is the Boltzmann hypothesis? It states that the absolute entropy, S, is equal to the Boltzmann constant, Kb, times the natural log of W. And W is the number of microstates. So I guess we should discuss how to work out how many microstates a system has. So a macro state, macro being something on the large scale, is basically the thermodynamic state of the system. So that is going to be measurable or observable quantities, things like pressure, temperature, volume, etc. So that is going to be on, if you like, the larger scale. A microstate is going to be the different number of equivalent ways that individual like particles, for example, could be arranged that is going to be energetically equivalent to that same macrostate. So a microstate is the number of equivalent, I guess, arrangements within the macro state. Okay, so if we have a macro state which has not very many microstates, like say there's only two possible sites for adsorption, the macro state would be the molecule is adhered on the surface. The microstate is there are two possible ways that could happen. One way is on one site and one way is on the other site. So there's only two possible microstates. So the more possible microstates you have, the higher the entropy of the system is going to be, the more disordered it can be. And that basically correlates with probability. The more possible microstates you have for one macrostate of interest, that means the more disordered that system, the higher the entropy, and that's going to relate to higher probability. So entropy is kind of analogous to probability. The more ways that something can happen, the more likely it is to happen. So one other thing we need to know is what the Boltzmann constant is. So Boltzmann constant is just going to be a constant K subscript B, and the number is 1.38065 times 10 to the power of minus 23, and the units are joules per Kelvin. So now we have everything we need to solve this kind of problem. We're told that the oxygen molecule is adsorbed onto one of 784 possible sites. So if those sites are all equivalent, the macrostate would be an oxygen molecule is adsorbed onto the surface, and the microstates would be what specific site the oxygen molecule would be adsorbed onto, and all those sites are equivalent. So there are 784 equivalent ways that that system can be in order to equate to the macrostate of the molecules on the surface. So that's 784 macrostates. So we can just substitute straight in. So S equals KB, so 1.38065 times 10 to the power of minus 23 joules per Kelvin times the natural log of 784. So you may need to, get creative with the parentheses here. Whatever your calculator wants, you must appease the calculator. So I get S equals 9.2012-ish times 10 to the power of minus 23 joules per Kelvin. And we are asked for three significant digits, so 9.20 is absolutely fine and dandy.